Word of the day is keep pushing no matter what happens. Okay, so A makes the graph positive or negative. So when the graph is positive, you draw it in the first and the third quadrant. If it's negative, it's going to be in the second and the fourth quadrant. There we go. I'll show you now what that means. P, you write it as x plus p equals to 0. And then that will be your x asymptote. It will all make sense in a second. Right. Q is your y asymptote. So you write that as is. There's no q plus something. So it's written as is. And there we go. So let's apply the knowledge. So we are given the function. So we first need to write down the asymptotes. So you're going to write x minus 1 equals to 0. X is therefore equal to 1. And the y asymptote, y equals to the value that's given there, which is 2. We write it down as is. Okay, so determine the x and y intercepts. So let's go. X-intercept, you have to set y equal to 0. So we put 0 in the place of y, so that's 2 over x minus 1 plus 2. So now it transposes 2 over, so it's going to be 2 over x minus 1. And we multiply by x minus 1 on both sides. That cancels out the denominator on the right, so that gives me 2 minus 2, x minus 1 in brackets, equals to 2. There we go. So it's minus 2x plus 2, when you multiply it out, equals to 2. And then we transpose it to make positive 2 over, it becomes negative, so it's going to be 2 minus 2. Negative 2x equals to 0. We divide by negative 2 both sides, and therefore x is equal to 0. Now we write it in coordinate form, 0 and 0. And then my y-intercept, I set x equal to 0. There we go. So it's going to be y equals to 2 over 0 minus 1 plus 2. So if we simplify this, y is therefore equal to 0. Right? So write it in coordinate form. So you see the x and the y intercepts, they are the same. Then let's check the graph. Okay, and there we go. They're cutting at 0 and 0 for both intercepts. So we add our asymptotes. We know that our y asymptote is 2. It's a line that the graph always approaches but never touches. Okay, and then we draw the vertical asymptote, cutting the x-axis at 1. There we go. And so now there's two common questions that you get when you have this type of graph. They can ask you in the exam, what is the domain? Domain refers to the x-axis. You can see here that the graph continues to the right. So it's all the way to positive infinity. And it also continues to the left. So we can say that x is an element of real numbers, because it continues forever to the positive infinity and forever to the negative infinity. But there's a place where the graph never touches. And therefore we will make the following statement. X cannot be equal to 1, as you can see where the asymptote is, and that's how you determine the domain. Let's do the range. The range refers to the y-axis, so it continues forever upwards and downwards. So y is the element of real numbers 2, where y, where is the asymptote, cannot be equal to 2. And you got that right if you said 2. Okay.